Thank you very much. Thank you very much. I'm glad to be here. This is going to be my talk about why you don't have to compromise Agile at all when you're building regulated medical products. A lot of times I hear people say, well, we can't really use Agile in a full sense, or we can't do all the practices because of our industry. And it's just not true. There we go. So, first a little bit about my background. I've worked all my technical career in safety critical products in several industries. I started with flight simulation, and I'll say a little bit more about that in a minute. But I've also worked in sonar weaponry and industrial controls, like factory machinery, scientific instrumentation, and also medical devices. Since around 2002, I've really concentrated on coaching Agile teams, mostly concentrated in embedded systems work or more the engineering side, although I have coached some teams in financial services. I've been active in the Agile community since pretty early on, and well, you may know some about that already, but I'm also on the board at our Agile group in Boston. It's called Agile New England. So I keep busy with those things. A little bit more about my flight simulation background. One of the things about it is we never separated hardware and software when it came to designing the flight panels in the simulators. We had the same group of engineers do that, the hardware and the software engineering. I did both. My background educationally was electronic engineering and also computer science. And so it was great to put those together and always keep them together. So I just mentioned that because it seems like we're coming back around to that with Agile. But I also want to mention, in doing that type of work, I learned a lot about the kind of training that's necessary when people are working in really complex systems where it's possible to get into, well, people call it a meltdown situation, where events can cascade in a very fast fashion. You know, you can imagine if you have an emergency on an aircraft, or other kinds of similar meltdowns happen in finance and other places. I'm getting ahead of myself a little bit. But one of the things about flight training is we did an awful lot of things to make the experience using the flight simulator be true to life, because it was really critical that pilots learn to act totally automatically in the situation. A lot of things had to go just from memory. That kind of runs a little bit against my grain, because I think everybody should think things through and be independent thinkers. And but it is necessary in certain kinds of situations. But it's got to complement real problem solving. I'll say some more about that as we go a little further. I want to give a special thanks to my colleague Brian Shoemaker, who helped prepare some of the content for today's talk. We often team up together, especially when we're dealing with medical device clients. And I've got a little bulletin coming through. I think I'm going to pick the restart option here. Let me take a minute and just poll the audience a little bit here. How many people are working in safety critical industries of some sort in the group? I see a few hands coming up, not too many. Anybody working in medical devices by any chance? No? I'm not sure I see any. Okay, well. Okay, I'm going to pick a restart for U.S. shutdown. I have a little thesis statement for my talk today. This is Brian's influence. He starts his talks this way. And actually, it occurred to me that that's sensible. It's like having a goal for your sprint. So my point here today is that you don't have to dial back your Agile methods in any sense because you're building a safety critical application. Agile, when it's done correctly, when you're using the technical practices, test-driven design, unit tests, kinds of things we've been hearing about already today, Agile is inherently safer and better than the methods we used before it came along. It smoothly combines the knowledge of the whole team, and it creates a feedback loop that creates an inherent kind of risk mitigation, but through the process, in addition to the risk mitigations that you could put in your product. here's what we're going to cover today. I want to talk first a little bit about safety critical products in general and just give you a mental framework for this. Then I want to get into some tips that I think would be useful in case you find yourself working in some type of safety critical applications, especially if they are medical devices. I won't go too deep into all the boring regulations and, and standards documents. Try to avoid that, but keep it topical. Okay. I'd like to start out by describing a nuclear accident that happened in the U.S. back in 1979. In this situation, this was 3 Mile Island, which is near Harrisburg, Pennsylvania. At the time, I lived in New York State, roughly 150 miles north of that area. A friend of mine was living in the locality of 3 Mile Island because she was there for college. In this nuclear accident, it was quite a sequence of events, but I'll be brief about it. The key part of it had to do with a stuck valve that triggered the initial problem, which was it allowed water to leave the nuclear core. Okay, there are times when you need to take the level of the water down. Sometimes you need to increase it. But too much or too little water is a real serious problem in a nuclear power plant. So in this instance, this pressure relief valve was stuck open. Now, that started a lot of alarms going off, right? As you can imagine. In the operator room, they saw a light which said that the valve is closed. And so they started to think, oh, we've got probably too much water in the nuclear core. Now the problem here is the light was showing them the commanded position of the valve, not the actual position. So the real fact was they had too little water. They thought they had too much. So they were starting to deal with that when another emergency system came on and started flooding more water into the core because that system knew there was too little water. So the operators were almost in a panic by this point, and they're trying to defeat that. So many more things happened, but eventually it got under control before it went too far. And there was an investigation later, and a little bit of diversity happened, which was a good thing. Normally these investigation panels are just lawyers and engineers, and someone in the loop suggested that they have this person, Professor Charles Perot, be on the investigation panel. Well, that was a good thing because he came from a sociology background, and that meant he looked at the problem in a very different way. He knew that, and a lot of the facts, if you look closely, would tell you, but he knew that this was not operator error. This wasn't any big root cause, the kind that we design for, or that we mitigate against. This was instead, the real significant thing to him was that this was sort of meltdown by 1,000 cuts in a way, because it was a series of mundane little problems, a stuck valve, an ambiguous light, things like this, and there were more than that. There were a series of little mundane kind of problems that are all independent. So if you were going to try to analyze for that type of problem in advance, the combinatorials would just be unimaginable. So that struck him as a really significant problem. He took more of an interest in this type of thing and wrote about it in detail many years. Some of his findings are described here on this sheet. I'll just summarize it. Some of it's written and described in a book called Meltdown, which is pictured here and which came out last year. This story is from that book. Now, the interesting thing is the way that Professor Perot decided to think about situations that can get into a meltdown kind of a condition. And he said there were 2 factors. Just raw complexity of the system, okay, and that goes beyond things that we ordinarily think of as complex, like assembly lines and things like that. This is complexity on a sort of another scale. And he also borrowed a term from engineering, and he called it tight coupling, meaning there are plenty of things that are complex, but you've got time to think it through. There's enough circuit breakers, if you will, that doesn't have to get into a meltdown kind of a situation, a really hot and heavy. One thing I forgot to mention about the thing at 3 Mile Island is that sequence of events that I described, that happened all in 13 seconds. And it was only 10 minutes before permanent damage to the core was done. So that's how fast, once the event got rolling. Anyway, so he said, so this tight coupling is another characteristic. And then he made a chart that I think this kind of thinking appeals to folks at this conference. He made this chart where he said, let's look at some situations of this kind of coupling and complexity. And so in this chart, he shows at the lower left things that are not so complex and where you have time to think things through. So an organization like a post office or even assembly line production, because it's fairly well planned out. A little more complex, maybe, or at least a little more tightly coupled because the events have more timing involved with them. Also on the more simpler end, but more tightly coupled, is he shows dams. Okay, a dam is not that complex, at least conceptually, but when things start to happen, they can cascade quickly. If you move over to the right, this is where he describes more complex things. And of course, in the upper right there, this is what he terms as a danger zone. That's the term he gave to the kinds of organizations and the kinds of industries that get into these problems and that he took a special interest in. So I just wanted to set that as a backdrop for what I'm talking about today when we discuss medical and other safety critical kinds of work using Agile methods. I've got another story I want to tell also about another meltdown situation in a very different industry from what I just covered. And this story is also told in the same book. I think it's interesting because when they train medical emergency teams, they often use simulation, like we did at the company where I first worked. Building simulators to train pilots. We had all the NASA contracts, the big airlines, the military, trained astronauts and everybody. In fact, some of the engineers I went to work with at that place, they had helped in the Apollo 13 rescue because people didn't know how to do this. There was no procedure for how you use the lunar excursion module as a lifeboat in order to abort the mission and scoot back to Earth. Nobody knew how to do that. They had to invent the procedure on the fly. And the quickest way they could do it was to get the simulator to teach them what it would and wouldn't do. And some of those engineers were still working at the company when I came to work there. Anyway, come on to my other story. It's about a medical situation where they were using a training exercise. And I'll just give you the background on how this training exercise works. They'll use a mannequin as the patient, and to make the situation realistic, this is sort of a high-tech mannequin that can give off life signs and all this kind of thing. And the mannequin is worked automatically in an adjoining room by other medical students who can see the situation and will make certain signals happen, like make the patient seem like they have no pulse, or make the patient seem like they're breathing or not, things like that. So they use that so that they can then run the same scenario for different medical teams for training. And so I'm going to describe the scenario for you and what one of the medical teams did. Okay, they bring in a young boy who's had an asthma problem. He's conscious when he arrives, but he loses consciousness pretty soon after arrival. And then he stops breathing. So right away, the first thing the medical team does is they have it's a bag with a mask on it. They squeeze that bag and it helps bring air into the patient's lung. So they start doing this. They don't see his chest rising, and at the same time, his pulse dies away. And so now they're really concerned about his breathing, so they insert a breathing tube. That doesn't seem to be doing anything. So one of the other medical professionals there recommends, no, let's remove the breathing tube and let's try the bag again. So they try the bag. That doesn't seem to be working. One of the doctors begins to use a defibrillator because they're worried that his heart's going to stop. Well, this team, they can feel that they're spinning their wheels. And by the time they're doing all of these things, more than 10 minutes has gone by. So if this was a real situation, the patient would have died. Now, these kind of teams were studied by a researcher named Marlies Christensen, who I believe is at University of Toronto. And the situation there is, what she got curious, what's the difference between the teams that succeed and the teams that don't succeed? Because the thing that is a bit worrying is that somewhere around half or more than half of the teams didn't solve the problem in time. So in their situations, the patient would have died. So here's some information about what she found. She looked at the teams, the medical teams, who really did a superior job. And there was a strong pattern there. She found that those teams were able to balance doing patient tasks, the tube, the bag, things like this, doing the tasks, monitoring, seeing what effect that had, and then coming back and thinking about a diagnosis or revising the diagnosis that they had. They were able to do these things, and the best teams of the ones who kind of did all these activities, the best would actually talk it out. I have a little diagram of what that looks like. What she came up with is she noticed that if they went through a rapid cycle where they did tasks, they did monitoring, they did the diagnosis, and the conversation looked kind of like it's shown in these little dots on the screen. If they cycled through all of those things and did it rapidly, those were the best teams of all. Some teams tended to get stuck. They would get stuck in one task and just keep trying to make it work and not come back and look at the bigger picture. Some would, all their talk would be about the task, then monitoring, then the task, and the monitoring, and they didn't come back around to rethink the diagnosis. Those teams didn't do as well. It was only the ones who went all the way around the cycle and went around quickly. Now, to me, that's kind of describing an agile process, And when I read this, I thought, geez, this kind of makes the case in a way. So let me move on a little bit here. So in this danger zone type of situations, the lessons that we take away from it are that a lot of systems can cause meltdowns due to multiple root causes, seemingly unrelated. Once started, the events tend to happen really fast. There's much pressure. There tends to be a lot of confusion. You can't really do complete problem solving right there on the scene. You need to have a certain amount of training and a certain amount of things that you know to do automatically. But you still have to do some problem solving in the moment, I think. So you've either got to cope pretty rapidly or not have these situations happen. So far, we've not been able to 100% prevent them. So we need a way to cope. I'll next turn your attention to the life cycle and medical problems because I want to get into talking about risk management there. I have a couple of slides to show you. I want to show you some examples of what real companies have been doing. First of all, a little overview of what the life cycle looks like for medical development. Lots of these stages of product development can go by different names, and I've shown them on this chart. But these are pretty natural. There's preparatory and feasibility stages that you do before you get into the bulk of your development work. And then there's a final test period and some type of deployment. In medical product development, the stage right after final test is where the regulatory system comes into the picture. If you're in the US or if you're under FDA type rules, you're going to make a submission to the FDA at that time. It's a document that you prepare. And if you're successful, you will get permission to market your device, to market and sell it. In the European Union, it's a very similar process, just looks a little different. You will undergo a CE mark inspection, and if that's successful, you get permission to sell your product. Okay. I'll show you a couple of examples next of how real companies described their product development. They went through these processes. First, we'll look at one from a company called Omnix. And you see right in the center, they're showing the Scrum diagram about the development cycle. And they also capture a process that they use for the inputs into development, the preparedness and the feasibility, and a release process at the right-hand edge of the diagram. Okay, now they actually included a diagram like this in their submission to the FDA. Another company called Synchronous, they described their model as a fuzzy V model, which I kind of like. And again, they explain that in the center of that V model, where the coding box happens, this is where they use their Agile process. And in their description, they also talk about the parts to the left and to the right of that as being where they also have feedback loops. I just don't show it all in this diagram. But anyway, that's where their Agile development happens. Incidentally, I thought it would be interesting to show you the stages of development that each story goes through inside of a sprint. That's given here on the on this chart. It's more than just doing done, started doing done. It's a little more than that. They like to show peer review and independent test for each of their stories as they go through their sprints. Okay. Talking about sprints, I just want to show something about what the regulators think on this. There are some standards that acknowledge the value of working iteratively and that also govern risk management. And these two documents are pictured here. And the names are kind of always long and boring, TIR 8002 and all this kind of thing. I'm going to try and spare you too much of the alphabet soup and just kind of get to the content. But the overall point is that there are people in the regulatory world, in the FDA, in the European Union regulatory bodies, who really get it and understand about Agile. They really understand that this can be the ticket to a lot of the root causes of accidents that they're just tired of having to deal with, and they're tired of having to try to be policemen over things where they can't really control it. So they're in a position where they have to see that you have some kind of a process. They need to understand what your process is and have some kind of a trail that they can look at to decide whether or not they believe you're following your process. Okay? And so that's the position they're in. The quote here in the box, I've got this type of thing throughout the presentation where there's a quote from a regulatory document or an advisory. So I won't read all of this to you, but essentially they're acknowledging that having a cyclic life cycle is an aid, is a help for risk management. That's an important point. So let's get into our next section, which is about risk management. I think I need to adjust this. Okay. Hope that's okay. All right. For risk management. So let's talk about what the regulators say about risk management. In one of the documents, this is one of the standards, 14971, it says that the manufacturer has to establish and document and maintain throughout the life cycle an ongoing process, for analyzing, evaluating, and controlling risks. Now, that sounds to me like they're trying to say, don't just do it once at the start of your project, right? Revisit it as you're evolving your project, or product, I should say. That's what they're trying to say. Now, they don't just come right out and say, hey, use Agile, because it's not their role. They both, US and European Union, both have the same philosophy that they're not trying to promote or ban any type of a process. That's up to the company, but they are in the role of making sure you have a process, it addresses certain aspects that matter to them, and that you are following it. That's essentially it. So they can't come out and say, use Agile. But when you read the documents, you can almost see that they're trying to say it without using the word. What I do and my colleagues, when we're working with medical device companies, we recommend that they look at their stories in the manner that's shown here. Think about it as, of course, we know how to break down requirements into stories. That's not new. But when you do your hazard analysis, you're going to come up with mitigations that you need to put into your product. They might be done in software, they might be done in hardware, but you're going to mitigate against risks that you foresee. So that set of mitigations and stories, the mitigations can be written as stories and they should be tagged as such. And that whole conglomeration becomes your set of requirements or your as-built, once your features are complete. The industry has the same problem with hazard analysis that the software development industry before Agile had with testing, right? We made it into such a heavy process that nobody wanted to do it more than once, so they do it at the end of the project. Well, they've made hazard analysis into such a heavy process. They only want to do it once at the beginning. But there's nothing that stands in the way of making it a lighter weight process. And once you do that and you revisit it periodically throughout the development period, you're better off. I'll also mention, too, that a root cause of many of some of the worst accidents has been that there was some kind of a mitigation somewhere in the software that later got wiped away or changed because people didn't realize it was there as part of a risk mitigation. Later changes in the product either changed it in a bad way or got rid of it. And some of those kinds of root causes are really nasty. Okay, just mentioning that. So let's look at what Agile says. Pairing is one of the practices. And we know about that. We know that it can be very effective. Well, the news is that you can use pairing as your peer review. You can document your pairing process, and you can say, this is how we peer review our work. You just have to address the regulatory concerns, okay? They're going to want to know that you have some acceptance criteria established, and of course we all do that for our stories, right? We have conditions of satisfaction or acceptance criteria, and we have other things for our every stories too, right? Like definition of ready, done, things like that. They want to know that reviewers are qualified, so the peer reviewer can't just be anybody. It's got to be someone with the right qualifications, understands the work. And you need to just document the results, which should not be difficult, with the systems that we have for tracking our stories already. So the quote here at the bottom about pairing, this comes from a document called TIR 45. It means Technical Information Review. It's not a standard. It's not mandated. The standards and the legal requirements, those are mandatory. There are other advisory documents, and this is one type of an advisory document. They are considered very influential because they have to go through a process where they're reviewed by regulatory people, and they're sort of given a go-ahead, but they don't have the strength of a standard, just so you know. So what else Agile says? I don't mean to say that pairing is the only risk mitigation thing that's built into Agile. Really, almost everything about Agile is risk mitigation at the process level. But all the practices here that include feedback loops are really key for what I was just talking about, risk mitigation throughout the project. So I think all of these tend to accelerate the learning, and they tend to converge the knowledge of the group, or at least of a pair. And this, in my mind, is systemic risk mitigation. I wouldn't be complete in this section about risk mitigation if I didn't mention fault tree analysis and FMEA, also failure modes effect analysis. Are people here familiar with this? Anybody ever tangled with FTA or FMEA? I'll just give you a brief definition. I see a couple of hands. I'll just give you a brief definition. Fault tree analysis is something that you can do at any time. You can do it before you even have a design in place. You can do it at any other later time in your project. And it's where you identify some outcome that you don't want to have happen, like you don't want the patient to die. But you got to be more specific than that. What are you going to do if certain things could happen? Any given product has some kind of an inherent risk. Like patient could get a shock, patient could get cut, things like that. You identify what that is, and then you look at what pathways lead up to that. And for each one of those pathways that could lead to the event, you put in some type of a mitigation to keep that from happening. Fair enough. Back when I was working at GE years ago, one of the things we were working on defense systems for Navy, for submarines, and one of the fault tree analysis things we actually did, this was after the project was running, so it wasn't at the concept phase, it was into it. We did a fault tree to guard against the event of having an inadvertent missile launch from a submarine. So we had to trace through the code and find all the logic paths that could lead to that. And then we had to make sure there were a certain number of decision points in each path. If there were too few, we had to add more because it was all a probabilities game. So that was kind of interesting for fault tree analysis. FMEA is a very depth-first and very well-respected technique for looking at what would happen if a given component in your design fails. So you have to have your design in place in order to do an FMEA. But you're typically looking for root causes that you can identify in advance, and then you're doing the analysis for only one root cause. Now, if you want to consider multiple root causes, you just do multiple FMEAs, but this can be pretty labor-intensive. So I think that this is, I think that we have a problem here. If you look back at the example I gave at the start about the nuclear issue, that was independent, little mundane problems, the kind of thing we blow past all the time every day. They just happened at a certain combination at a certain time to really create a disaster. I have trouble imagining how I would have prevented that, even though I have these kinds of analysis tools at hand. So I think there's progress to be made on this front, both for Agile teams and for the industry in general. Moving right along here, I'd like to close up talking about risk management in the product lifecycle using this diagram. Think of this yellow arrow as your project lifecycle. You have your thoughts about your intended use. With only that, you can start doing fault tree analysis if you'd like. You get into a concept phase. Now this is kind of the feasibility, and you can do some cyclical work at this stage. At this point, I'm showing the typical Agile development pattern. Like a Scrum cycle, or whether you're using Kanban or any other flavor of Agile. We're talking about this is the period where you're cranking out your features and testing as you go. Okay, but because you're evolving your product, you can introduce new hazards at any point along the way, and that's the idea. At some point, you want to launch either your initial version of your product, or maybe you're doing an upgrade. Whatever it is, you've got a package of features, you're ready to put them out. This is where you deal with the regulators to get your permission to go. Once your project is out, post-market, customers are going to use and they're going to misuse your product in ways you didn't foresee. I guarantee it. And so you're still not done with risk management. In fact, you're still not done with risk management even after you've stopped marketing your product. You still have to continue it after sales and service have stopped, as long as it's out there in people's hands. So risk management is very much an ongoing thing. I'm going to move next to the section about formal design review. Now, this is kind of a scary topic, or it can be, for people who just don't know what really matters about it to regulators. Where I used to work, people always made it into a big scary thing, and I realize now that a lot of that was unnecessary. In formal design reviews, what regulators need is you've just got to have your software plans. You've got to define the reviews that take place. You've got to show that they satisfy the regulatory requirements. That's really what you have to do. No one in any regulatory body tells you what process you have to use, as I mentioned already. You get to decide what process you're using, but you have to then show that you have a process, that you're following it, and that your product's going to be safe and effective, right? All those fun things. So a lot of that's in your control. Okay, so what do they want as part of a formal design review? Well, the kind of pattern that many people think they need to do when they go Agile is these little cycles here are showing your normal sprints, and the little blue diamond there is meant to show your sprint demos, right? So you're doing sprints, and maybe you're doing a demo, or if you're using a continuous flow kind of thing, you still want to have periodic demos. So most people would organize a formal design review towards the end of that when they're going to get ready to deploy. You can do that, but there's no reason why every sprint demo can't be a formal design review, because with the way we can track our stories and just do a lot of our documentation automatically, you're probably already doing this. If you have a good, solid, agile set of practices going, you're already doing most of everything the regulators would look for. So just take credit for the work you're already doing. At every demo, you could create a memo to file, and all it's got to do is contain 4 items. Your meeting date, who attended, what kind of things got discussed, any action items, who took them, things like that. Just put that into your design history file. If you just do that at each demo, now you've got a record. And when questions come up, you can show. You can show, we looked at that, this was working at this point in time. That's all going to be helpful to you. Every demo can just be a formal design review, and then there's even fewer surprises can come up when you go to do your regulatory submission. Okay, documentation. Let's talk about this. This is another thing that this is a real headache for an awful lot of medical device companies. They let it get away from them, and again, by breaking stuff down and doing what a good Agile team just does, you can get rid of an awful lot of the documentation problem. Showing a diagram again, this typical little stages of a common life cycle. And here I'm showing the names of lots of documents. These are not mandated. These are just typical documents that companies have. I'm sure you're all familiar with things like a SRS, Systems Requirement Spec, SDD, System Design Document, things like that. Nothing says you have to have documents by these names or that you have to organize your information in these documents, but you'll have to have something. You'll have to say what documents you do have and what they are. That's fine. Now, first of all, for an Agile team, one of the first things I did with my own Agile team is we got rid of some of the documentation headache by saying, look, our executable tests are part of our documentation. We're not going to write a document every time we test our code. That's crazy. So a lot of things, we're already past that stage. So some of the headache goes away simply by using the automation that you can use. I also want to make the point, I've already said it here, this words that I clicked in, you don't have to have any set number of documents or by the names they are. A lot of companies go into a life cycle like this when they change to Agile. I'm sure you've all experienced it, where they start working in sprints, but they use the same title and description of their traditional documents. They just fill the content in incrementally, so to speak, so that your requirements document keeps growing with every sprint and this sort of thing. That's okay. I don't have a problem with that. It's usually the easiest way for companies to get into this, and then sometimes they will start to think about reorganizing these things. So far, I don't tend to see too much of that, though. Okay, so I want to, as part of talking about documentations, I want to say something about regulatory submissions, because this is an area also where companies ask for help when they're moving to Agile. Myself and my colleagues, we say to them, look, one of the most common mistakes people make is they want to tell the whole story, the soap opera of how their design evolved, and they want to put all that in the document. And we say, no, don't do that, because you're just going to confuse people, and it doesn't matter now. If you started off on this design path and then you changed to this path for some other reason, it just doesn't matter now. Only write about what your design is at the time you're submitting it. Just, you don't have to tell all the loops and turns in your development. Just show that you have a process, show that you followed it, you know where all the evidence is. That's it. And you obviously have to show that your product is safe and effective. Any studies that you've done, things like that, you have evidence for those. A couple more things. There's something called a level of concern, and what that means is It's not exactly analyzing the risk potential inside your product. It's more like the what level of harm could occur if your product didn't work as intended. And so that goes by a couple of different names in the US or EU, but the whole idea is you need to state what your level of concern is. For instance, your product might, the worst it can do is give people some incorrect information. Okay, that's a low level of concern then. If your product could give people minor injuries, a cut or something like that, then that's another level of concern, and so on. And you need to document what level of concern you think is appropriate for your product and what evidence you have for saying that. You also obviously would need to document any third-party software that is in your product. And that's it for talking about documentation. So in conclusion, I have a little bit of information I'd like to cycle back here. And I just want to say, when I think about the information that I went over at the beginning here, Christensen's findings to me are really telling. They're really describing that it's an agile process that takes the best teams to where they need to be. The cycle of things, balancing, reasoning about the situation with actually doing stuff. To me, that sounds so much like, what do they call it, strong type pairing, or anytime you're pairing with somebody, right? Somebody's close in dealing with the tasks, and the other person is taking a turn at thinking about the overall situation. Okay, so going around that cycle in a rapid fashion, but orderly, and creating some transparency into the thinking. The people would sort of narrate what they're thinking and what they're seeing, for everybody around them so that they could all participate in the thinking. To me, that's the essence. In fact, that kind of sounds like a mob programming team to me. I'm sure Woody would recognize it as such. And her research also showed that it just shows us in this kind of danger zone situation that, as Perot calls it, that fast loops through the agile idea of an inspect and adapt loop are the thing to do. That's it. You don't have to compromise that. And that's all I mean. I want to close with some examples of companies that are actually using agile practices. I don't mean to say that the company's 100% agile. Some of these are huge companies, but we know of people within these companies, teams within them, that are making significant use of agile practices in their medical device work. So that's kind of a long list. I'll give you a minute to look at that. I'm finished with my content part. Now I just want to make an announcement. I want to let people know that a book that Brian and I collaborated on is published. It came out last year. I'm pleased to say it's only 109 pages, and it's really intended for people who are in the medical device field and are agile curious, or they're wondering if agile can work for them, but they may be convinced of it or heard of it, but not so sure they want to actually try it. So it's meant to address the kind of concerns that they have. Having said what I did about the type of teams that do best in meltdown situations, it occurred to me that I should make a mention of our Agile Games and Mob Programming conferences. They're coming up in Boston. I'm one of the organizers of that, and we've been doing those for, Agile Games is now in its 10th year, and Mob Programming its 4th year. So there's a little mention of that. It's coming up April 8th through 12th. I've got notes and references, so when you get slides later, you can have all that. And Brian and I will be teaching our course in Berlin just a couple weeks from now. We're doing our Agile Intro course, which is for basically middle managers in medical device companies who are Agile curious. And we've got a brand new advanced course for people who are in that industry and been using Agile to some extent and want to take it a little bit deeper. And that's what I have for now. We do have time for some questions. So if you'd like to ask a question, feel free. Any hands?
Can't see any hands. We've got a nice microphone over here that can be thrown to catch. Oh, we've got one over here. I feel like we should do a dance while we're in. Good catch.
So you briefly touched on generating some of the information that you need to provide to regulators. How far do you take that? Do you like go as far to pull that information from like your tests, or how does that work? It sounds interesting.
Well, you're asking how deep do you go in proving that you tested your software?
Yeah, and how much of it do you automate? How far do you take the automation?
Could you move the mic a little bit closer?
Okay.
Sorry.
He said, how far do you take your automation? Well, you don't have to automate it any further than you want to, but they will be interested in knowing that you've done adequate testing, at least to ensure that any hazards have been examined sufficiently so that that you can be confident they're not going to happen. They're not going to comb through your code because that's not their expertise. They're going to want to. They will stay at the level of documents if you can't show them that the mitigations for hazard number 5 have been tested, and that there's a document showing they were tested. That's probably the depth that they're going to look at.
Thank you.
Yeah, so to some extent you're on your honor, but they will look for some evidence, and they'll cross-check it with other people. Okay, they'll ask. They might go and ask more than one source. Can you show me the evidence for when you tested this? So that would be how they get at the truth.
Thanks.
Any other questions? I don't think I see any hands.
I have a quick question. If you do think of any, and you don't want to ask them at this point,
That's all right. I'll be
Nancy will
around
be
at
around.
lunchtime, and I'm going to be here tomorrow too.
So my question was, do you think we'll be able to take some of these tips of working of Agile with regulations and use some of them to work with more traditional firms that have quite high levels of governance and work in more of an ITIL sort of fashion?
Yes, but you might want to question what you're governing and why, is kind of what I feel like when I see companies that have imposed a lot of heavy process on themselves, or maybe they feel that others have. I should also mention, one of the things I see all the time, probably should have said it in the talk here, is that all the time I encounter companies who have an imagined fear of what the regulators will do or what an auditor will want to see. And so they will, how do we put this? They'll not document some things that they should, or they'll not go out and do the extra testing that they should because they're afraid that that's going to be a flag that gets the regulators to come and look again. To me, I just see them wasting a lot of time. I see them wasting a lot of time and effort trying to avoid just being upfront about what they should. I'm not saying every regulator, every person who'll come in and review your documents is always clued into Agile, but you can get them to understand it. That's one of the things we help managers do. That's one of the things they ask us. They say, well, if I do this, I'm afraid my regulatory affairs people are going to be all over me. I'm afraid my QA and test people are going to be all over me if I tell them engineering is going Agile. They're going to be afraid. So we help to provide them the rationale. We say, no, this is the more solid way of doing engineering. What we were doing before just wasn't as robust. In fact, somebody yesterday was asking me about that. He said, well, I kind of, been part of the DDD community for a long time, and we come from, a lot of analysis and design. He says, I haven't seen Agile teams be as rigorous as I think they should be. And I thought, wow, to me, that's what attracted me to it, because I mean, my own team, we were moving in that direction before Agile got a name, okay? So we were just kind of assembling practices that different people knew about. And one of those practices was sort of like test first. It wasn't automated, but it was unit testing. And my team and I tried doing it, and we were crazy to take data. We always took data about everything we did. And we saw what a difference it made, and we were just amazed. And we started combining that with some other things. Pretty soon we had most of the set of practices that make up extreme programming. But I mean, for us, it was led by the greater rigor of doing real Agile. Later on, we started to learn more about retrospectives and other more people-centered kind of practices of Agile. So I would say it's very rigorous, and I don't know a whole lot about ITIL, but from, I mean, I would just say there's a lot of management things that they want to do, and to me, if they're not really focused on the product, on customers, you got to ask questions like why. But all these practices will help you do what you need to do. That's my 2 cents.
It might even help with convincing some of them that this is quite a rigorous process. It's using regulation.
Mm-hmm.
Thank you.
Yeah, and all the other regulatory schemes are of a similar philosophy from, like other industries. Medical tends to be the strictest, so others tend to pattern themselves on it. So, if medical people are doing this and they believe in it, and it's working for them, yeah.
That's the best
it. Thank you. Thanks for your attention today.
Thank you very much, Nancy.
Okay.